Hi, this is Bits and Pieces, the official podcast of Component Supply. I'm Kristin.
And I'm Mark.
And today we're going to start a little mini-series called This or That. So this comes from questions that we get, right, of a customer saying, when should I use this versus when should I use that? So that's what we're going to name the podcast episode. This is going to be this or that materials.
Some materials.
Some materials.
Not all materials.
Not all the materials. And we're going to just kind of live in our space of what we supply. So kind of the high level, though, is we deal with hypodermic tubing and wire. Those are like, kind of bread and butter products for us. And we sell a lot of those. We fabricate a lot of those. So the main question then becomes 304 versus 316. So I would say most of the time already spec'd on the drawing, for the most part, is 304. Mm-hmm. When we would see 3016,
good job.
Good heavens, 316 is typically for the environment that it's going to be in the application. So if it's a more corrosion resistant material. So I automatically think of the customer who one time was like, I thought stainless steel was supposed to be corrosion resistant, and in my application, it's already rusted. I've only had it for 24 hours and it's rusted. And we're like, oh, that's really strange. Did you do something to it? Well, yeah, I put it in a chloride solution, really like heavy chloride solution for 24 hours. It's already rusting. I'm like, yeah, it's not corrosion proof, right? Like there's a difference. You can't just take these materials and do whatever you want to them and expect nothing to happen. They are reactive. There is a component, there is a corrosion that can happen depending on what it's in. But
right.
Yes, if you were to put 304 in, it would have happened much faster. But 316, it's still going to happen, right? So you just have to be mindful. But if you are going to expose it to a corrosion, a corrosive environment, then 316 is typically the way to go. Are there any differences in mechanical properties in our shop that we see, or any reasons that you would prefer a customer or recommend a customer to use 316 instead of 304?
Yes.
Good answer.
Right? There's always a give and take. So, right, the one I use as the example is, you like a saltwater fishing boat.
Yeah. Right.
You'll see where they'll attach something to that using a screw, and those screws are generally 316. Because if you put a 304 stainless, screw in it, over time it will corrode, it will rust in a saltwater environment. 316 won't as much. However, there's a give and a take there. 316 is softer, so now all of a sudden you've attached whatever to this boat, but you've kind of used from a structural standpoint an inferior product because it is not as strong. The material is softer than 304, and so you've got to kind of take that into consideration.
Right.
Same with kind of any other principle, right? With any other product, you're going to give up some strength when you move to 316 over 304. In the medical device or other industries, there are applications that doesn't matter. You're not really where a fastener is a big deal, so you've got to consider that. But that is something you give up in order to gain sort of a higher corrosion resistance. You're going to give up some strength.
I think that's an important thing to remember when you are selecting your components for the medical device industry right at the beginning. You can't have it all. That is just the truth. If you pick something here, you're going to give up something here. That with any of these comparisons that we're going to make with materials, when we're talking about capabilities, when we're talking about different processes that we're doing for making a catheter mandrel or something like that, you're always giving away something. You want a thinner OD or a smaller OD. But you want to stick a bunch of stuff through the tube. You're going to deal with a thinner wall thickness that's going to affect strength. So there's give and take with all of these, this or that. So just up at front, there's not really a right or wrong answer, right? It depends on your application, and it depends on what's characteristics of the material or of the overall device are most important. So at the beginning phases, component supply is always going to, we don't always get the opportunity to know your end use or what your goal is with the material, but when we do and we can provide insight there, we always want to steer you toward, materials that are readily available, but that are also able to meet your needs. So we're not going to, for example, someone will be like, "Can I put this in the human body?" And I'm like, "It's 304." No. Don't do that. Don't
leave it there.
Yeah, don't leave it there, right? That's a tooling aid, that's a processing aid, that's something that might be like temporary to assist you with a procedure. It is not titanium. It's not something that's going to stay in your body. So there are obvious ways that these materials can't or shouldn't be used when you're going through this or that. But 304, 360, they're very similar. The main key point with that one is the corrosion resistance. Yeah. But yes, you're always going to sacrifice something else when you get the benefit of another
That's
thing.
Right. When people ask the question, generally it's like, which one's best?
Mm-hmm.
And we hate to be that person that answers a question with a question, but the reason we do is
Jesus did it.
I know, but I'm not putting us on his level. So, the reason we do is it's not one's best. There's not a best answer, right? Now all of a sudden it's the best for that application. So when somebody says what's the best, now all of a sudden we've got to go through, okay, what's the environment? What's the application? What kind of strength do you need? What are those? Mm-hmm. What are the features that you're looking for so that we can figure out what's best in that moment or for mm-hmm. that application?
Yeah. Yeah.
Which is why we answer that question with a question.
Yeah. So, you have like kind of base metal stuff. When you're dealing with wire, a lot of times we'll get some questions about different coatings. So, a PTFE coating versus, a no PTFE. So we have like Glide Med. Surface Solutions has this great Glide Med coating that people are using. This is when there's, some hesitancy around PFAs and all of these things. So when to use what? As far as a coating goes. So we even have customers that are like, we want a natural coating. This is be special order. So our coatings are blues and greens and grays. Mm-hmm. And they might want something natural in it. It's like a pure PTFE. Because what matters to them more than anything is lubricity mm-hmm. versus, a durability. Maybe it's a one-time use kind of thing. So they're not quite as worried about it lasting for multiple uses. So that's one that we get a lot. When should I use PTFE versus when should I use Glide Med? And there are, Surface Solutions has tons of different coatings that you can use. They're fantastic. But that's one. PTFE versus
like a low PTFE.
A low PTFE or no PTFE coating. What are some of the issues that we have come across as we're working with this stuff? Like our shop gives us a lot of feedback when we're working with these coatings.
If you ask anyone in our shop, they would say always use Glide Med.
Yeah.
But
why? Why do they like working with it?
It's easier to work. The PTFE coating can be removed very easily. Like that has to be handled so carefully.
And this is typically like, what are we doing in the shop when we're messing with a PTFE coated wire or mandrel? We're like typically performing some sort of inform.
We're either cutting it or we're removing some section of the coating, mm-hmm. or we're grinding some profile in some section of that wire, mm-hmm. and so or yes, an inform, or whether it's a radius or whatever that is, and so. You're handling it, or you're holding the material holding, which can damage it, mm-hmm. And you can be handling with your hand, and if the environment isn't right, you can scratch that coating mm-hmm. off. I don't want to say like easily, but you can, and so when you go to these other coatings, the low PTFE and no PTFE, they're harder.
Yeah.
And so you don't experience that. But you give up some stuff.
Yeah. You give up a little lubricity.
You give up some lubricity.
But if you don't need all of that, if you don't need the exact same, smoothness or lubricity, when working with Glide Med is great for like a multi-use mandrel mm-hmm. potentially, or just a situation where you need it to work for longer or for more, or it's approaching something that's a little bit more abrasive. Mm-hmm. So yeah, even in component supply, our team has preferences, so we can give that feedback just in good faith and good knowledge that we've done this before. The Glide Med is great. If you can use that, and also if you do have any concerns with some of the regulatory stuff that's going on, but lots of variety there. But on our shelf, it's the Glide Med 0%, 5%, and then just a PTFE kind of standard green coating. And people then kind of going from there for this or that, like color preferences.
Sure. That
deals more with like oftentimes if it's used as some kind of a depth gauge, visibility becomes important. So and that's a preferential thing. We've had some people that are like, we like this green, or we like blue, or it's more of a preference thing from our perspective. I'm not saying there aren't other reasons to choose different colors, but what we see oftentimes is just for the tool maker, the operator.
I think the operator too. They've got, they may have one mandrel that is green already, and they're going to introduce a new one for a different product line, and they want to make sure they separate it. And so for just for
categories,
they're going to make this one gray so that there is a visual difference between those two, and they don't accidentally pull this one out. They can write it into their processes and easily distinguish the difference between them.
Yeah, well, that's why each of ours is a different color. Like we didn't do all of our coatings are not all green because we wanted to make sure there was a distinction there. If someone wants like a Glide Med in green, we will special order that. But the off-the-shelf components, we've got the different colors just to help everyone stay organized.
I think that was just for me, so I didn't.
Mostly for Mark. No, but I think it's helpful to our warehouse, and especially if someone's like testing, like they'll want one of each kind of coated mandrel, and then it's very clear which is which. Okay, so we've dealt with the metal side. We've dealt with the coating of those metals. We've got these mesh products we've talked about before. We have a nylon versus polyester. Which one should I use? That's probably, I think, in a product category perspective, that's when we get the most questions on, should I use nylon or polyester? And, you've mentioned this, and it's probably good to repeat that some of these products, the availability of them are not based on the medical device industry, right? They're based on screen printing in the case of the mesh products. And so nylon has a larger variety. So if you're needing lots of different options at the ready on the shelf, nylon will give you more of those options. But polyester has some oftentimes preferred characteristics. Do you want to dive in?
I do. In our industry, for that specifically for like filtration and separation, nylon is acceptable most of the time.
Yeah.
In an environment where it's just exposed to water constantly. Nylon has some problems. It absorbs water, gets brittle. However, so many companies that we supply to in the aquaculture industry using it for applications that are fully exposed to water. There's where the material is submerged. They choose nylon.
Right.
And I think it's price, availability. Nylon has more options from a size standpoint. And so I think they typically just use nylon and then replace it.
That reminds me of something. Hang on, I'm gonna look up something. On our very easy to use website, shameless plug. So we, just from the medical perspective, that it made me think of our biopsy bags, which I don't always do a very good job of promoting, but a lot of our like university customers and those more like laboratory sciences are using these, and they do come in nylon and polyester. So there is you can choose both. It's not like they're like, oh, polyester is more like better for the corrosion resistance. We're going to use that for polyester for biopsy bags. They give you both options. So it's not like you're pigeonholed into using one material because you have one application. It really just depends. What are you using to filter? What are you filtering through? What environment is that going to be in? Lots of different options, even in medical. But you're right. I initially I thought aquaculture was only going to use polyester because of the corrosion resistance thing, but it just depends on what the actual application is. And a lot of times they'll grab both materials and they'll test it and decide, because even if we don't have the exact same offering for polyester as we do for nylon, it's close enough in a lot of applications, right?
Well, we've seen where you go. We don't do a lot of like the plankton nets, but if you go to these companies that sell into the aquaculture industry, they'll sell these plankton nets, and they're polypropylene.
Yeah.
They're polyester, and then on the flip side, we have people who are doing larva separation for crustaceans, and they're using nylon. That's completely submerged for long periods of time.
Yeah. And
they're using nylon in that application, but on a net, they're going to use so I think some of this winds up being, this is just what they've always done. And and there was no reason not to. There's no reason to change, plankton. There's no reason to change, larva
it's working
separation.
for them.
Yeah. So, but this is where I feel like companies did their due diligence. They tested and found out, nylon's fine. I can use that.
Yeah.
Or vice versa. They did the testing and said, I feel more confident with the polyester. So in terms of the this or that, sometimes it's ultimately down to your own testing.
Yeah.
We can give you some guidance one way or the other. We can show you the specifications. We can give you some of the material properties, and you may find that this one works better for you, and you're okay with that.
It reminds me of, you tell us sometimes, just because we've always done it this way doesn't mean it's not incredibly stupid. Like sometimes people are, the this or that is based on what you've always done. So in the case of whether it's a material choice, particularly here, capability choice, sometimes people are speccing stuff out because they always have, and they would rather pick the one. It might not even be the most desired material, but it's too much work to go back and do a revision on a drawing. And so that's why I think it's so important to have these conversations in the beginning. If you're looking for long-term use of something, if you are going to spec it on a drawing, get it right early on, so you don't have to get down the pipeline and think, oh man, we should have used this material because it's more accessible. We would have had a shorter lead time if we would have just used off-the-shelf material. So having those conversations early with your suppliers, whether it's component supplier or someone else, I think is incredibly important. Have the this or that conversation as early as possible,
right.
So you don't have to say like, why are you using this material? Well, we just always have done it that way. That's the worst answer to get. It makes my heart hurt a little bit, because I'm like, man, you could have, this was so cheap, or oh man, we have millions of feet of that on the shelf, and you're using this like super specialized alloy for something that doesn't really matter, for tooling.
Right.
It doesn't matter. Why are you doing that? Because they had overrun of someone's product at one point versus picking something that was readily available and actually benefited their long-term application. Anyway, that's a little sidebar for you. Okay, let's do one more. Let's do one more of a material, and then let's do like rapid fire this or that for like other things, just funsies. Okay, you ready?
Sure.
Okay, let's do PTFE, FEP first, because a lot of people are using those as heat shrink components. They're used for like catheter reflow processes. They're used for maintenance and repair. We dabble in aerospace. We dabble in some other industries. So we see lots of different uses for that. But I think, for people who are watching this, particularly a lot of you are, R&D, catheter kind. So can we talk about PTFE versus FEP?
I would love to talk about nothing less than this.
Nothing less than this?
Yeah, nothing less.
Okay. So you don't want to talk about it? Do you want notes?
You have the notes. I have the rapid fire.
Yes.
Okay.
Go for it. Off the cuff. Let's go. He's drinking coffee. We'll wait.
What would you like to know about whether we should use the PTFE?
Just what are the differences? I'm not gonna ask you like what's your favorite. It's not like your color. Blue or green?
So, PTFE versus FEP.
Yeah.
They're both 4 feet long in our warehouse.
No.
You can get them 6 feet
That's
long.
false.
Oh, that's right. We do have some
Thanks to Lightning Cap, we've got some long
6 foot FEP.
Yeah, people love that. They do not like to be limited.
This is sometimes I think the medical device industry got kind of shafted over time.
Shafted like catheter.
But the reality is, like so much of this was aerospace based. The PTFE either the extruded material or the shrink tubing was used as jacketing in their electrical harnesses. And then obviously there's it's moved over. There was lots of applications in the medical industry as well. Then the catheter production side using FEP as in the process to construct a catheter. Those are kind of the two. You've got these two materials, PTFE and FEP. Generally, people are going to run to the in the medical industry for catheter production. You're going to run to FEP. PTFE has a higher recovery temperature, and that makes it unnecessary.
They'll use it as a liner.
They'll use it as a liner, but not as a recovery because they don't. So that's an extruded tubing. It's not a shrink tubing.
Super thin wall.
Right. They'll etch it, but it's not a shrink tubing. It's not, something's being recovered onto that. But if they were to use, again, if you use PTFE, you're heating that up really too much.
Yeah.
It's too hot.
Well, it's interesting with the PTFE and the FEP. So there's, this question of definition of what is medical device as far as when you're categorizing your industry, right? So there are some companies that would say, using it as a tooling is not in medical. Like it's used for tooling a catheter, but they would still put that in like the industrial bucket. Right. They would put the PTFE liner in the medical bucket, and they would put the heat shrink in the industrial. But like we've had these conversations before, and I find that so fascinating. So this versus that, man, we've really messed up, I think, in some ways, trying to categorize what is medical versus what is not medical.
Yes.
But in the same way that the FEP has from when you're doing the catheter reflow and you're recovering that, it's used in the same way in lots of other industries. So I can see why they put it in the bucket of more of an industrial side. They see it used the same way in aerospace. They see it used the same way in like automotive.
Yeah, I think companies have to make a choice. They either choose to separate it by an application or like it's what it is, right?
Yeah.
So they, if you define this thing as, okay, well, it's either, it comes in contact with the human body, or it goes, it
touches something that comes in contact.
Right. If you define it something like that, then all of a sudden its shape or the product itself doesn't matter. So a tubing can any tubing could fall into that category.
I like that we have a broader approach, that we're just like, if it is servicing the medical device industry, it's medical in component supplies mind. Even if it has more of the industrial side of the use. I like that we think of it that way. We treat it seriously. It's not just, we don't just cast it off to the side of that's
our
not
history,
medical.
going back, to small parts and the group that we were around with Dr. Murphy, didn't look at products that way. It didn't matter what industry it came out of. If there was a use that could further life, there was a way to incorporate that. They were going to use it. They didn't kind of pigeonhole that and say, well, that's not really medical device. And thankfully, so they would look at jewelers' tools as a way to create tooling for their devices. They would look at different materials. They would look at mesh, from a screen printing.
It lets you open your world a little bit to know what's available, and again, like kind of this cross-industry collaboration, I think, which is so beneficial versus just like pigeonholing yourself because this material is medical, this material is not.
Right.
I think that's been a really fascinating conversation. It's just, for me, I'm like, let's just simplify this. Let's just simplify the process.
Yeah, and there's a time to kind of obviously bring it back. You don't want people going too crazy here. But at the same time, there has to be a group that says, I'm not going to stay in the box. And so just because this has always been used, or whatever, always for the longest time, always my career has been used in that application, doesn't mean it's the best. It doesn't mean it's the only thing. And so when you talk about this or that, this is that area that's like, should I use this or that? We're going to tell you, hey, these are the properties, these are the things you can get away with. But the reality is there's development out there. And so take what we've said, take what we've learned, take what we're passing along, but understand that there is the group out there that needs to try something different. You know, heat it up more than it should be heated up. Stretch it further than it should be stretched. I mean, this is the basis and the fundamental behind development. Saying that we're the authority or anybody's the authority on this or that is dangerous. We're going to help guide, but please understand we're also going to be willing to say, if you think that's worth a shot, you know, what's the other saying we have in our shop?
What's the worst that can happen? Yeah, I think that's right. I think selecting components in the early stages of R&D, selecting components that are readily available, that can scale with you, like that's in the early phase, that's when to ask the this or that question. It's not just about the differences between these materials. It is what's more readily available, what is going to be easiest to scale, what is going to be the most manufacturable component. I think we're not always asking those questions until we're way down the pipeline, and then we're trying to evaluate cost. And we're like, oh man, if we would have had this or that conversation earlier, we would already be in trial. But instead, you know, we're having to go back to the drawing board because our prototype was too expensive. And so I think, you know, we're saying all these things, this or that, 304, 316. But the point is, have the conversations early. Like, look at the full scope of what's available to you. Don't just pick something because it's better. It's not necessarily better for your application. Better in your application might just mean it's more expensive when another less expensive component would have done just fine. So I think those are kinds of the things to be evaluating as we go forward.
I think the other thing too, on the flip side of that, is it's not always more expensive. So for example, sometimes 316 isn't really more expensive. And if it's better for the application, while it might not be sitting on the shelf as readily available, it doesn't mean that it's really not any more expensive to produce if the project moves to, you know, into production that makes sense.
Yeah, especially if you have the flexibility in your timeline to have a ramp up period. It's not a big deal. Like, so yeah, don't you're exactly right. Don't put something off the table because you think it might, stereotypically it's more expensive, or at this time, at this point, at some point in your planning, it was too expensive.
Or it wasn't listed on our website.
Yeah, yes. Call for pricing. I know that's the worst. We will do better. All right, this or that, rapid fire. Tea or coffee?
Coffee.
100% coffee.
Okay.
Mountains or ocean?
I mean, right now in my life, mountains. It was ocean, but you know, we moved to Tennessee.
Well, what do you like better?
Right now, mountains.
Okay, well, there you go.
This is hard.
I can't make a decision. There is no this or that for me. I want both all the time.
Mountains overlooking the ocean.
Eastern time zone or Central time zone?
Oh, I like the Central time zone.
I do like Central time zone. I do not like that we are right on the border, and so it gets dark so stinking early, but
that's mean.
It's just really hard.
Yeah.
Let's see. What are other rapid fire ones? Stephanie, help me out. I'm putting you on the spot. We should have thought about this before. Would you rather life experience or college degree?
Life experience.
Oh, I like it.
Beef or chicken?
I was going to say that.
Oh, come on.
100% steak.
Yeah, for real.
Fries or tater tots?
Oh,
French fries.
Preferably sweet potato fries with some kind of garlic.
Regular fries
sauce.
or waffle fries?
Waffle. Yeah, why is so much based around food?
That's all I think about is food. Anyone who ever has met me at a trade show knows I am like particularly concerned about where my next meal is coming from, and it's like what steak place is coming next. Yeah, we live in a small town. There are not a ton of great food options. So we have a few that we like, but yeah, I'm always thinking about the next thing. Anyway, that's our this first that, this or that episode. We're going to be doing a few of these throughout the year just to try and give you an idea of what's out there, availability. If you have specific questions about your application, when we do these, we do try and be really broad because we know we have lots of different industry people that, you know, we send these clips to if they're curious about something. So we try and keep it pretty high level, but happy to dive in with you with the specifics. If you need certain, you know, technical data sheets, if you need material certificates, if you need something that's more specific so you can get a better feel for what you're using, we're happy to provide those. So never hesitate to ask the detailed question about your application after you see a very high level, broad podcast. We'll help you through those steps. Do you have anything to add?
Yeah.
All right.
This is it.
Let's go change the world.